Find all points of discontinuity of f where f is defined by following expression. So we have x less than or equal to 1 for the expression x to the power of 10 minus 1. So if the function is given an input which is less than or equal to 1, this would be the expression. For greater than 1, this is the expression. Now, before 1 and after 1, things will be continuous. At 1 is what we have to figure out. Let me show that. The graph looks weird, but yeah, this is how it is. So let me zoom in. The main part is over here. So that's my input, and we can see when we have the negative, since it's x to the power of 10, 10 is an even number, so it is always positive and it grows exponentially in a huge power because it's 10, right? And between -1 to 1, since the numbers are fraction and 10 to the power of, or any fraction to the power of 10 is a very small number, since we're subtracting with -1, approximately it is always -1. And so we have all of this to be -1 and all of that. And at 1 it is 0 because 1 to the power of 10 is 1, 1 minus 1 is 0. But after 1 we can see there's a jump. So there's a discontinuity at this point. Okay, if not, yeah, we have the following diagram. Now, how do you put it across? So we have three different cases. First is case let C be less than 1 and C belong to R. So what can we tell with this? We can tell limit f of x as x tends towards C. Since it's a polynomial expression, it is continuous throughout, x to the power of 10 minus 1, and so this is c to the power of 10 minus 1. And after this we have f of c. So here in this case it's c to the power of 10 minus 1, which is nothing but limit f of x as x tends towards c. Now next case would be let c be greater than 0 and c belong to R, not x, sorry, c belong to R, right? Here we have the expression limit f of x as x tends towards c. Any point more than 1 we have the behavior to be x square, and this is equal to c square. And we have f of c in this case to be c square as well, which is equal to limit f of x as x tends towards c. So till now things are continuous, not an issue. Now c is equal to 1. So we have to consider three different cases. Limit x tending towards 1 from the left hand side. So that would go with this behavior. As you can see over here, the left hand side we have this particular expression. Okay, so we have limit x to the power of 10 minus 1 as x approaches 1. So on substitution, on direct substitution, that is, we have it to be equal to 0. Right? Actually, I should have not done this, to be honest, because right hand side would have made more sense. We actually will do right hand side. That won't be equal to your f of 1, right? And thus we will have the answer. So this is x square and this will be 1 square, so this will be equal to 1. Now f of 1 would be equal to what? Would be equal to 1 to the power of 10 minus 1. This is equal to 0. So that's why the jump. And so we can tell this is not equal to limit x tending towards 1 from the right hand side will not be equal to this. It's not equal to 0, right? Or f of 1. Okay. I was confused if I wrote that right or wrong. Yeah. So all in all, what can I tell? F of x is discontinuous only at x is equal to 1. That's it. Again, be smart, understand what side you should approach, and check out the behavior. If the behavior is continuous, then yeah, we have to prove from left hand side and right hand side things are equal to f of whatever that value is.